Okay, let's try this one. FeO3, 1. Okay, so we have one iron there, one iron there, one carbon, all good. Oxygen 3 plus 1, there's 4 oxygen, and there's 2 oxygens here. Let's try the oxygen. If we do a 2 here, that makes it 4 oxygens, and makes it 4 oxygens on that side, but 2 carbons, so we have to put a 2 here. We have somewhat of an issue here. Now, notice that these are almost identical. The only way these numbers must be the same in front of the CO2 as the CO, because it's the only place that the carbon exists on both sides. So these numbers have to be the same. The problem is the oxygen, balancing the oxygen. And because there's 2 here and there's just a 1 here, but there's a 3 here, so this kind of throws everything off. Now this is a back and forth thing with balancing. You're going to go back and forth and try different things. And the more practice with this, the more tricks or things you can try. So what I'm going to try is I know that this is going to throw things off, so I'm just going to give it a big number. Let's just try 10. What happens if we throw a 10 out there? So a 10, that means we have to put a 10 here. So that means we have 20 oxygens. All we really care about right now is the oxygens, because the carbons will balance with that. The iron is easy. That's easy. So we have 20 oxygens here. We have 10 oxygens plus 3 oxygens. And we cannot get up to 20 that way. The closest we can get is multiplying that by a 3. We'll get a 9. Let's try multiplying it by 9. We just got to experiment. Put a 9 there. Now, we have 18 oxygens here. Okay, we have 9 oxygens, and then 3 times 3, that's 9. So we have 18 oxygens on this side. Okay, that's balanced. That's the hard stuff. So we had a 3 here. Now all we have to do is put a 3 here. I love this little metal here. Easy, makes it easy. So we're balanced. The thing is, you just have to keep playing around. Maybe if you're going back and forth, back and forth, back and forth, throw out a huge number like this. See what you get. Okay, let's try the next one. We notice that we have some polyatomics here. We have a sulfate here and 2 sulfates there. We have a polyatomic hydroxide, but there's no polyatomic on that side, so we can't count that as a polyatomic. We're going to have to count them as individual atoms. Now, the leads are balanced. The hydrogens are balanced. The only thing that's not balanced, no, the hydrogens are not balanced. We have 2 hydrogens here, and we have 4 hydrogens there. That's 6 hydrogens. And we have 4 oxygens. So we have a total of 6 hydrogens and 4 oxygens. But on this side we have 2 hydrogens and 1 oxygen. Let's first just balance these sulfates. Let's put a 2 here. That makes it 4 plus 4, that's 8 hydrogens. And we have 2. Now let's put a 4 here and see what we get. We have 8 hydrogens there. And 4 oxygens. Oh, okay, great, we're balanced. Let's look at this next one here. Aluminum plus hydrochloric acid, aluminum chloride plus hydrogen. Now, hey, loving that metal. Yeah, love it. All alone, we can say that for last. Let's try the chlorines. Now, if I didn't know better, I'd just say, well, let's just put a 3 here. That balances the chlorines, but then there's 3 here, and oh, well, let's see, that's going to cause a problem. I'm just going to multiply this by 2 to make it easier. because this H2 is going to give us problems with this. So let's make that even. 6 chlorines. The alumins we don't care about. We got this, my boy, right there. That's all right. We don't have to deal with that. So we don't care about the aluminums. It's going to be easy to deal with later. 2 times CO3. That's 6. Let's put a 6 there. That's 6 H's. Now we can put a 3 here. That's much easier to deal with. That's 6 H's there, 6 H's on the left. So we're balanced. You got to put that little 2A there, 2AL. There we go. Okay, that's why we want this guy last. Let's look at the second to last one. This looks like a bear. We have a lot of polyatomics here. We have a phosphate here and here. And oh, look at this. This looks hard, but if we break it down into polyatomics, we can even just keep H2 by itself. Let's just keep that. And the thing is, we're lucky because we have an H2 here. So let's keep these sulfates together, phosphates together. Okay, let's just balance those as is. Just keep those in mind. I'm going to erase these and make it a little easier to see. Sulfates, and then the phosphates. Again, let's just separate those. So we have the phosphates here. We have 2 phosphates on this side and 2 phosphates on that side. That's balanced. We have 1 sulfate here and then 1 sulfate on the reactants. That's balanced. But the hydrogens here, the hydrogen gas, the diatomic here, there's 2 here, which multiplied by this, that means there's 2 groups of H2, but there's just 1 group of H2 here. So I'm going to put a 2 here. And then let's see what we get. Then the only problem here is the sulfate is now unbalanced. Let's put a 2 in front of the sulfate. Those are balanced. Let's look at the calcium. So there's 3 calcium on this side. There's 2 calcium here plus 1 calcium there. That's 3 calcium. Hey, it's balanced. Wow, we kind of lucked out there. It kind of all depends. Sometimes they look like a bear, but sometimes they're not. It also depends on what you start with. If you start with something else, it would have got you down on the wrong track. So at times, it looks like you're just taking forever on a certain balancing problem and it's just getting really crazy, start with another element. Start balancing another thing. For instance, I could have started balancing with the calcium and then I could have gotten in a really big trouble. If you find yourself just going in circles, just start over, try balancing with something else. Okay, now how about this next one? Well, we have a polyatomic here, but the polyatomic goes away, so we're going to have to count atoms there. It doesn't count. Well, we have 4 hydrogens on this side. We have 4 hydrogens, 4 oxygens, we have 1 phosphorus, 1 phosphorus here, 1 chlorine, and 5 chlorines on that side, and 2 hydrogens there. Okay, I see this 5 here. I just kind of sense it's going to give me trouble. So I'm going to multiply it by 2 just ahead of time. So I'm going to change that to 10 chlorines. So let's just start there. We have 2 phosphates and 10 chlorines. So we're going to have to put a 10 chlorine here. I'm just going to erase these. Okay, so the chlorines are balanced. The phosphoruses, we're going to have to put a 2 here. Phosphoruses are balanced. But the hydrogens, we have 6, 10 here, hydrogens. So that is a 16. Let's put an 8 here, and sometimes we'll see what happens. So that's hydrogens are balanced. Now that's 8 oxygens. And looky here, we kind of got lucky here. 8 oxygens here, 2 times 4, it's 8 oxygens there. That worked. It just takes practice. Keep doing it over and over.